New York State, Algebra 2, Regents. Common Core, basic graphs of trigonometric functions. Range of y is equivalent to the secant of x. Concept number 12. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. So inbox me at memedicine@gmail.com to order this complete cram session. If this isn't the topic you're looking for, no worries. Still inbox me at memedicine@gmail.com for personalized packages. Be sure to spread the word to your friends and classmates who also need to cram. Let's cram the concept of the range of the secant of x. Basic graphs of trigonometric functions. Range of secant of x. Now the key to progressing through this entire concept is getting things in order. So before we actually get to the concept, I want you to recall a few things. Here we have our xy Cartesian coordinate plane, and we see here that we have an acute angle in standard position. Now this angle is acute because it's between the quadrantal angles 0 degrees and 90 degrees. And it's in standard position because the origin is the point of the vertex, the initial side ray is on the x-axis, and the terminal side ray terminates within quadrant 1, again between the angles 0 degrees and the quadrantal angle 90 degrees, okay? Now, if we resolve the terminal side ray into its x and y components, what we have is the formation of a right triangle. We'll indicate that here. Okay. All right. So with these attributes, we can say that the secant of theta, and here we're calling our angle theta rather than x because we're using x as our x coordinate. So for this pre-example, we don't want to double up on variables x and x, but we still mean the same thing. You know, we're finding the secant of some particular angle. Okay, so the secant of theta is going to be the magnitude of the terminal side ray. And I specify magnitude because we're not dealing with a coordinate point here. We're actually dealing with the length of the ray. So because this is a length or a distance, it's always going to be positive. Okay, that's another important concept to keep in mind. So the secant of theta again is the magnitude of the terminal side ray divided by the x-coordinate. And I specify x-coordinate here because that's exactly what we're dealing with. And you need to note that the x-coordinate can be positive in quadrants 1 and quadrants 4. Likewise, when you're dealing with trigonometric functions that incorporate the y-coordinate is positive in quadrants 1 and 2, negative in quadrants 3 and 4. And note that the x-coordinate is negative in quadrants 3 and 2, okay? All right, I also want you to note that the secant of theta is the reciprocal of the cosine of theta, okay? Which is basically, oh man, I hate scribbling. Okay, that's basically going to be equivalent to, don't have enough space, x, the x-coordinate of the ray, the terminal side ray of the angle divided by the magnitude of the terminal side ray, which is also going to be the hypotenuse, or the longest side. Now, this is a convention when we're dealing with a right triangle formation in a Cartesian coordinate plane, but let's say that this were just some triangle, not even necessarily right, outside of a Cartesian coordinate system. The secant of theta would be the hypotenuse, or the longest side, divided by the bottom line, or the initial side ray of that angle, k, or the adjacent side. And the cosine would be the adjacent side, or the bottom side of that angle, divided by the longest side of the triangle, or the hypotenuse, okay? All right. Oh yeah, I said this angle was in standard position and it's acute. All these features make it basically a reference angle. And it's a reference angle because when you are looking for a particular trigonometric value with regard, or let's say you do the inverse secant, the inverse sine, the inverse cosine, your calculator is always going to give you the reference angle. Whereas you may be looking for an obtuse angle that's located in quadrants 2, 3, or 4. So you have to know how to manipulate this reference angle to find out the specific either angle you're looking for or trigonometric value you're looking for, and you may have to manipulate the sign. So let me just show you what I mean really quickly. Let's say you do a vertical flip about the y-axis and your theta ends up over here. Okay? You may not necessarily be looking for theta, but you might want to know what's up with this angle, this obtuse angle that's adjacent to theta, okay? And the way you would get that particular angle is by subtracting theta from the extent of this quadrant, and the extent of this quadrant is the quadrantal angle, 180 degrees. And let's pretend, for example's sake, that theta is equivalent to 40 degrees. Then 180 degrees minus 40 degrees is going to be 140 degrees. So this angle would have a measure of 140 degrees. And let's say that you do a diagonal flip about the origin, and your theta ends up over here, okay? What you would now do to find out this particular bad boy is you would add theta to the extent of 180 degrees, because you're going theta beyond 180 degrees. And so in that case, you would get 220 degrees, okay? Or what you could do, no, actually no. And then let's say you're in quadrant 4 and you do a horizontal flip of theta, the reference angle, about the x-axis. And you're really interested in this angle right here, adjacent to theta, what you're going to do is subtract theta from the extent of quadrant 4, which is 360 degrees. And when you subtract 40 degrees from 360 degrees, what you're going to get is 320 degrees. Okay? All right. Okay, I think those are all the bases, the pre-bases at least, that I wanted to cover with you. So now for the concept. What is the range? And when I say range, I mean the set of all possible values of the dependent variable, or all the possible y coordinates, okay? And you only get a y coordinate by inputting an independent variable, or x coordinate, that occurs along the horizontal axis. So what is the range of the function y is equivalent to the secant of x? Definitely take a moment to press pause and draw out your solution in the form of a graph, and write a brief explanation of your reasoning for the range of the secant of x function. All right, so hopefully by now you are able to draw out a graph and come up with a solution. If not, that's totally fine. Here goes a graph of y is equivalent to the secant of x, okay? And basically the way you're going to find the range is to determine all the y values where the graph exists, okay? And a visual inspection shows us that y can either be a less than or equivalent to -1, or greater than or equivalent to 1, okay? And if you watched my domain of secant of x cram session, you would have known that basically the domain, or when I say domain, I mean the entire set of independent variables for this function, where the function or graph exists, is all real numbers except for odd multiples of pi over 2 or multiples of, yeah, basically. And that's again because we're looking at the x-coordinate, and there's no x-coordinate at odd multiples of pi over 2, such as 90 degrees, which is 1 pi over 2, or 270 degrees, which is 3 pi over 2. Okay? And yeah, all real numbers, because some people get confused on that, real numbers include counting numbers, such as integers. That the number that might occur over here, such as -3, or 0. 0 is an integer, it's a counting number that occurs along the number line, or something over here like 3. Okay, integers also, well, not integers, real numbers also include rational numbers. Rational numbers can be expressed as fractions. An example, a over b, where b is not equivalent to 0, but it can be b can implicitly be 1. So an example is 2 over 1, or 2 over 2/3, 2 over 3. And the cool thing about rational numbers, rather, when you convert their fractions to decimals, they terminate. So the fraction for 2 would be 2.0. And the fraction equivalent to 2/3 would be 0.6. It's like a repeating 6.